Hello students, in this lecture we will discuss our chapter number 5, magnetism and matter, and the lecture is magnetic moment of orbital electron. So in this lecture we will discuss about the magnetic moment of orbital electron. We know that in nature we have various matters. And we know that the matters are made up of molecules. Molecules are made up of atoms. Okay. Atoms are made up of subatomic particles. Now in subatomic particles we know that there are three subatomic particles: electron, proton and neutron. We know very well that proton and neutron lies inside the nucleus. Proton and neutron lies inside the nucleus, whereas electron is orbiting, or electron is revolving in outer orbits. Electron is revolving in outer orbits, and due to this orbital motion there is a little bit magnetization in a substance, but the one motion is left. While the electron is doing revolution or revolving all around the nucleus, due to the attraction force of nucleus, electron is revolving all around the nucleus, but at the same time the electron rotates on its own axis. At the same time, electron rotates on its own axis like Earth, and this motion is called rotational motion. When electron rotates on its own axis like Earth, so this motion is called spin motion or rotational motion. Okay, because the Earth is revolving all around the Sun in orbits, or various planets revolving all around the Sun in various orbits. Earth is also a planet, and at the same time that planet or Earth is revolving on its own axis. Due to that we know that day and night, due to rotational motion of Earth, and the time period of 1 year is due to the orbital motion of Earth. So in the same way electron is doing both motions, orbital motions all around the nucleus and the rotational motion or spin motion on its own axis. Okay, so you can write down like Earth, electron does both motions, orbital motion around the nucleus, and rotational and spin motion due to its rotation on its own axis. Write down. Then the second line we will write: because of these kind of motions magnetization get produced in the atom. Because of these kind of motions, magnetization magnetization produced in atom. Write down and make this diagram as well. This motion is called, suppose this is electron, so this motion is called orbital motion, and this motion is called, suppose this is electron, this motion is called spin okay, this motion is called spin on its own axis. Write down both the terms, very important. Okay, write down both the points, then we will write the next point related to this theory. Okay, so pause and note down points as well as diagram. Next point, write down due to या हम लिख सकते हैं, we can write here that the magnetization is more due to spin motion than orbital motion. स्पिन मोशन की वजह से ज़्यादा जो है मैग्नेटिक मोमेंट उसके अंदर इस्टेब्लिश होता है, ना कि उसके ऑर्बिटल मोशन की वजह से. ठीक है, द मैग्नेटाइजेशन इज मोर ड्यू टू स्पिन motion than orbital motion. Very important point, write down. Then the next one is the spinning electron behaves like current loop which has definite dipole moment. Spinning electron has a definite dipole moment. Spinning electron has a definite dipole moment because it behaves like a current loop. So both points are very important. The rotating or spinning electron behaves like current loop which has definite dipole moment. When electron rotates anti-clockwise, the direction of current is clockwise. When electron rotates anti-clockwise, the direction of current is opposite to the direction of motion of electron. We know this very well, that the direction of current is plus to minus. So this direction is always opposite to the motion of electron. So we can write here, when electron rotates anti-clockwise, then direction of current will be direction of current will be clockwise. Direction of current will be clockwise. Write down this point, very important. Direction of current is clockwise, and due to this and due to this and due to this upper part of loop behaves as south pole and the lower part behaves like north pole. So in moving charge and magnetism, we have already just studied this theory that if current is clockwise, take a simple look here. If the current is clockwise, then that phase behaves like south pole. This is clockwise, so it behaves like south pole. And if it is anti-clockwise, then it behaves like north pole. That is south pole, that is north pole. So if electron rotates anti-clockwise, then the direction of current will be clockwise, and due to this, upper part of the loop behaves like south pole and the lower part behaves like north pole, according to this law, Faraday's law, Lenz's law, already we have discussed. Okay, and moving charge in magnetism, in that chapter we have already studied this, that how will we decide that if current is flowing in a current carrying wire, that it will behave like a dipole, because the magnet cannot be monopole, the magnet cannot exist in a single pole, it always is a dipole. So if a current is flowing in a hair thin wire, although it has two poles, the part in which we are seeing the direction of current is clockwise, that part is called south pole, and opposite to that part there will be mirror image, so that part will behave like a north pole. Okay, so we have already studied in chapter number 4. So the lower part behaves like a north pole, because the magnet is always is a dipole, it cannot be a single pole. Okay, so write down both the points, very important. So now I will erase this and we will discuss the mathematical formulation of this. So before going into mathematical detail, you should write these topics. Okay, pause and note down. I will erase. Okay, the next one is suppose the loop is like this. Or suppose there are n turns in this, okay. So if the current is like flowing in this way, here we can assume south and north, or current is flowing in this way, there are n number of turns, so write down if area of loop is a, if area of loop is a number of turns capital N, and current number of turns is capital N, and current flowing in it is I. Current flowing is I. Then magnetic moment, what will be the magnetic moment? Magnetic moment M is equal to N into I into A. Magnetic moment will be N into I into A. We have taken N capital, so you can write down I multiplied by N into A. This is called dipole moment. M is equal to NIA. So next write down, let charge q is revolving with angular velocity omega in a circular path of radius r. Write down, let's charge q is rotating. Write down, if charge q is revolving with angular velocity, charge q is revolving with angular velocity omega, angular velocity omega in, suppose this is the electron, in path of radius r, then circular current in the orbit will be, circular current in the orbit will be what will be the circular current? So we can write here I is equal to current, charge flow per unit time. Charge flow per unit time is called current. So can we find T here? So definitely we can find. How? The value of T, if you take T like this, capital T, so we लिख सकते हैं, we can write, since omega is equal to 2 pi upon T, therefore T is equal to 2 pi upon omega. And we can also write that since V is equal to R omega, therefore omega is equal to V upon R, where V is linear velocity, So we can write here I is equal to Q upon T. In place of T we can write 2 pi upon omega. Omega will go up, or in place of omega we can write here V upon R. Okay, in place of omega we can write Q upon 2 pi upon omega. Omega will be here. At the place of omega we can write V upon R, so it will be 2 pi R is equal to I. This is the current. where v is linear velocity, write down. Current is qv upon 2 pi r, where v is linear velocity, qv upon 2 pi r, qv upon 2 pi r. Okay. So revolving electron acts like a circular loop of area pi r square. Revolving electron, note down, then I will erase, pause, and then write down all the things. Now I will write here. Okay. So right here, electron moves in circular path so area of current loop will be what will be the area? Pi r square. Area will be A is equal to pi r square. So M can be defined as, therefore M is equal to IA, or we can write at the place of I qv upon 2 pi r multiplied by area pi r square, pi cancel, r square cancel, so it will become qvr upon 2, write down, very important conclusion, qvr upon 2. Now we will establish a relation among these quantities, qvr upon 2. Okay, so we have already get one important formula, another one will be derived at this side. So first of all you write down. Now multiply this equation, multiplied and divide this equation by m and m. So what can we write here? So erase from this side, or you can write here multiply and divide above equation with pole strength small m, small m से इसको मल्टीप्लाई और डिवाइड करेंगे हम. So it will look like this. Erase here. I think that you must have noted down all the things whatever I have described on the board. Never miss anything, because these are the important derivations. You know that this chapter is completely theoretical. Most of the part of this chapter is theoretical. A little bit part is based on derivation or numerical. So it will become very important, because if something in this chapter is very rare, so that thing will be very important in that chapter. Okay, so note down, multiply by m, so it will look like this, m is equal to qvr upon multiplied by m multiplied by m. Now mvr is called angular momentum. mvr is called angular momentum. So we can write here m is equal to q upon 2m into L. Okay, where L is angular momentum. So we can write it is scalar form. It is a scalar form where L is equal to mvr is angular momentum, no problem, angular momentum. Okay, write down. In vector form we can write, in vector form, because angular momentum is a vector quantity, so dipole is also a vector quantity, magnetic moment is also vector quantity, so q by 2m and this side L. In vector form it will look like this. Okay, so write down. Then I will elaborate something more about this topic in this side. So I think you have noted down the values here. Now look at the board. Q by 2m is equal to m upon L. So we can write here. Q upon 2m is equal to m upon L. Okay. So write down about this term Q by 2m. So Q by 2m represents the ratio of, write down, Q by 2m represents ratio of magnetic moment and angular momentum, represents ratio of magnetic moment and angular momentum, and it is called gyromagnetic ratio. It is called gyromagnetic ratio. Okay. So some of the teachers or students pronounce it like gyromagnetic ratio, and the correct pronunciation is gyromagnetic ratio. Okay. Q by 2m, which is gyromagnetic ratio. This Q by 2m represents the magnetic moment and angular momentum, the ratio of, and it is called gyromagnetic ratio. Note it down, very important. Okay. Next point is also very important. For positive charge, direction of M and L is same. For negative charge, direction is different. For negative charge, the direction of M and L will be different. For positive charge, the direction of M and L will be same. Note down. Then we will derive an important relation which is called Bohr's magneton. So write down, pause and note down. Then I will erase and explain you the next point. Okay. Okay, then the next one is dipole moment by orbital motion of electron will be dipole moment due to orbital motion of electron. What we have derived q by 2m, so it will be E by 2me, mass of electron, okay, multiplied by L, because electron has negative sign, so you can write here m is equal to E minus 2me into L, where we know that L is angular momentum and m is the dipole moment. Now according to Bohr's postulate, according to Niels Bohr's quantum postulates, quantum postulate, what we can write at the place of L, we can write nh upon 2 pi, the quantum that the angular momentum will be integral multiplier of h upon 2 pi. This will be a integral multiple, this value will be an integer, so nh upon 2 pi. It is according to the Bohr's postulate of quantum theory that angular momentum is the integral multiple of h upon 2 pi. So we can write here nh upon 2 pi. So at the place of L we can substitute this value, or we are not just worrying about the sign, if we are only calculating the magnitude, so we can write magnitude m, what will be E upon 2me. We are not just worry about this minus sign, we are taking magnitude, or at the place of L we can write nh upon 2 pi, multiply these values, we can write here, what we can write, take the constant in one side, so we can write E multiplied by h into n, and here we can write 4 pi me, write down 4 pi me. So this value is constant, we know that this value is constant, it only depends on this integral multiple, okay. So E, the charge on electron, it is a constant value 1.6 into 10 raised to power minus 19. H is the Planck's constant, it is also constant, its value is already fixed. 4 pi is constant, mass of electron 9.1 into 10 raised to power minus 31. So all these terms E, H, 4 pi m is constant, it only directly proportional to n. This term E, H, here E, H upon 4 pi me is equal to mu b, called Bohr's magneton. Very important question in perspective of exam. Bohr's magneton, write down, very important, so many times This question have been asked in your examinations. So this mu b is called Bohr's magneton, and its value is Eh upon 4 pi me. It is called Bohr's magneton. And we can calculate its value. As well. What will be its value? Can you calculate it? What will be its value? Bohr's magneton. We can calculate in this side. First of all, erase this. So students, since it is a constant, so we can derive its value. So it will be mu b. What will be the value of Bohr's magneton? Mu b is equal to E, 1.6 into 10 raised to power minus 19. H, 6.6 into 10 raised to power minus 34. I think this is the value of Planck's constant, upon 4 pi multiplied by 9.1 into 10 raised to power minus 31. Solve this value. So I think that you will get, after solving this value, you will get 9.2 into 10 raised to power minus 24 ampere into meter square. 9.2 into 10 raised to power minus 24 ampere meter square. This will be the value of Bohr's magneton, or you can solve this value or write your answer in comment. If the value is not similar to the value that I have written on the board, you can tell me in your comment section. So students, that is enough for this lecture. We have discussed in this lecture the orbital motion of electron and spin motion of electron, the magnetic moment due to this motion, and the very important term that we have derived, the Bohr's magneton, the value of Bohr's magneton in 1 mark or 2 mark question. This question have been already asked so many times about the Bohr's magneton, and what we have derived, that the ratio, gyromagnetic ratio, Q upon 2m is equal to m upon L. The ratio of magnetic moment with angular momentum is called gyromagnetic ratio. The gyromagnetic ratio, the Bohr's magneton and the orbital motion of electron are the very important question in perspective of your examination, board examination, as well as you can find some small numericals in your competition section like NEET or IIT. So that's it for this lecture. Thank you very much.